Hello students, in this video we'll see an example of how to use the Laplace transform to solve an initial value problem. Let's solve the initial value problem. Y double prime minus 3y prime plus 2y equals 0 with the conditions that y of 0 is equal to 2 and y prime of 0 is equal to 3. So, as we've seen previously, we can take the Laplace transform of the equation. So, we will take the Laplace transform of the equation, y double prime minus 3y prime plus 2y. That will be the Laplace transform of 0. And let's simplify this. The Laplace transform of 0 is clearly 0. The Laplace transform of y double prime by our formula is s squared Laplace transform of y minus s y of 0 minus y prime of 0. Then I have 3 times the Laplace transform of y, so I'll have a minus 3 times s Laplace transform of y minus y of 0. And finally I'll have plus 2 the Laplace transform of y equals 0. Now we'll gather like terms and use our condition. So our condition tells us that y of 0 is equal to 2, so this will become a 2, this will become a 3, and this will become a 2. So we'll simplify. The coefficient of y tilde of s, we'll gather those terms. So y tilde of s is being multiplied by s squared. It's being multiplied by negative 3s. And it's being multiplied by 2. The other terms that are left are a minus 2s, a minus 3, and then I will have a negative 3 and then a negative 2. That will be a positive 6. And then those would be all my terms set equal to 0. Now we'll simplify. Over here I'll have a positive 3. So setting everything equal to the Laplace transform, I will have the Laplace transform of y is equal to a 2s, I'll put the 2s on the other side, a minus 3, and I will divide by this expression over here, s squared minus 3s plus 2. And what we'll do is we'll factor the denominator. We'll write this as 2s minus 3 over s minus 2 s minus 1. Because now we can use partial fractions. Partial fractions tells us this will be a over s minus 2 plus b over s minus 1. Now we can find a by multiplying both sides of this identity by s minus 2. So I will have 2 minus 3 over s minus 1 is a plus b times s minus 2 over s minus 1. And now into this equation, I can plug in s equals 2. And if we plug in s equals 2, this term with the b will cancel out. So I'll have that a is equal to 2 times 2 minus 3 is going to be a 4 minus 3 over 2 minus 1. So a is equal to 1. Similarly, we can multiply the equation by s plus 1 and conclude that 2s minus 3 over s minus 2 is equal to a, which we found to be 1, times s minus 1, plus b. And now into this equation, I will plug in s equals 1. So if we plug in s equals 1 into this equation over here, this term will cancel out. We will see that b is 2 minus 3 over 1 minus 2. So b will also be equal to 1. So what we have is we have that 2s minus 3 over s minus 2 times s minus 1 by my partial fractions decomposition is going to be 1 over s minus 2 plus 1 over s minus 1. And we can verify this is true simply by adding as well. I can now factor an s out of each of these denominators. If I factor an s out of this denominator, I will have 1 over s times 1 over 1 minus 2 over s. And if I factor an s out of this denominator, I will have a 1 over s, and then a 1 over 1 minus 1 over s. And we can check this works simply by multiplying back through. Now, both of these expressions are geometric series. So I can write down their Taylor expansions. The Taylor expansion for the first, I'll have a 1 over s. The sum from 0 to infinity of 2 over s to the power n plus 1 over s. The sum, n goes from 0 to infinity, of 1 over s to the power n. As before, we will do our trick where we multiply the top and bottom of each of these series by n factorial. So I'll have an n factorial over n factorial, and I'll have an n factorial over n factorial. If we do this, the first sum will become the sum n goes from 0 to infinity of n factorial over s to the n plus 1 times 2 to the power n over n factorial. The second series will be the sum, n goes from 0 to infinity, n factorial over s to the n plus 1 times 1 over n factorial. Now I will do the inverse Laplace transform of this and the inverse Laplace transform of this. We know that those will both inverse Laplace transform to t to the n. So when we do the inverse transform, we will get the series, the sum, n goes from 0 to infinity, of t to the n times 2 to the n over n factorial, plus the sum, n goes from 0 to infinity, of t to the n over n factorial. The first expression is the Taylor expansion for e to the 2t. e to the 2t is the first series. The second series is the Taylor expansion for simply e to the t. e to the t. So by inverse transforming, we arrive at the solution. And we can plug back in and check. This is simply d squared minus 3d plus 2. We know that both e to the 2t and e to the t are annihilated by that. And we can check the initial conditions. When I plug in 0 to this function, I get 2. When I plug in 0 to the derivative, I get 3. So indeed, we arrive at our solution. Thank you very much.